we are going to use our calculators to model quadratic data. So we will use it to find the best fit quadratic instead of us just willy-nilly drawing one in. And so that it has the least amount of error. And of course, as always, we will interpret our solutions in regards to the actual problem at hand. So maximizing profit, okay, we see a price per item in dollars. So $10 an item, $20 an item, etc., more expensive. And the profit in terms of millions of dollars. Okay, so price it at $10, you get $57 million of profit. Look at the data scatter plot and determine if it's quadratic or linear. Use your calculator to find the equation that best fits the data. Indicate what the variables represent. Okay, so I have taken the opportunity to go ahead and fill the data, but I want to remind you of how that went. So I went stat, hit enter on edit. In list 1, I put the prices per item. In list 2, I put the profit in millions of dollars. So 57 millions of dollars is what this would represent. Now I'm going to go second, y equals for stat plot. Hit enter again to turn it on. I do want a scatter plot. And remember that our x list is supposed to be our explanatory variable. So we're trying to say that price explains profit, and profit responds to the price per item we put on something. So in list 1 was price, and list 2 was the profit, and that is exactly how it should be. So now we're going to go to zoom, down to statistics, zoom 9, enter, and we see this graph. Okay. In addition to looking at the scatter plot, it wants an equation of best fit for this data. Okay, so I'm going to make a quick sketch of this data's scatter plot. Along the x-axis is our price per item. So this was list 1, and I'm going to call this P for price. And, oh man, or P for profit. Darn it. You know what? I'm going to call this M for money made. So we're bringing in the Benjamins here. So, and I put this into list 2. This was the explanatory variable. This was the responding variable. So this is price in dollars, and this was profit in millions of dollars. Okay, and the scatter plot looks something like here's one up here, and then here's one there, and a little bit there-ish, another one, and another one. Rough sketch of the scatter plot. I definitely look at this and I think, oh, that is way more quadratic. It's not perfect, but it's way more quadratic than it is linear. So, is this data quadratic or linear? Quadratic. Why? Because it curves and it goes up and comes back down. So I look for curvature. Is it curvy? And 2, I think, well, does it decrease then increase or increase then decrease? Because that is the telltale sign of a quadratic. Okay, use your calculator to find the equation that best fits this data. So back to the calculator and back to the data. I'm going to go stat, calculate, and instead of linear regression, I'm going to do a quadratic regression. So a quadreg at 5. Hit enter. My x, or explanatory variable, is in list 1, that's the price. My y list, which is the responding variable, is profit, that's in list 2. Compute. And notice that it's giving us the A for our general form of a quadratic, the B, and the C. It's giving us r squared instead of r, but that's fine. So this correlation, it's pretty strong, and we'll go ahead and maybe we'll round that to -0.06, if that's okay. Should we round it to negative 0.063? Meh. The more precision, the better. So, I don't know. Whatever. Let's just make a decision and go with it. Here we go. So profit, so money made is going to equal, is going to be approximately, because remember models are just a really good estimate, negative 0.063, okay, x squared, there's the ax squareds, plus 4.19 x's, and plus 24.4, and that was our c. Ooh, x. Do I really want to use x? No. I want to use p for price. I think x is too vague, honestly. P. Square the price. Yeah. Better. I like variables that mean something instead of are ambiguous. But as soon as I looked at the calculator, I was like, oh, let's call it x. No. Clearly indicate what each of your variables represents. So P, price per item, and M, millions of dollars in profit. Money. Got it. Number 2. What price will bring in the most amount of profit? Well, if it's a quadratic, so we decided here it was quadratic, so we used quadratic regression, yes. Then it has a vertex. That's the peak, maximum. Vertex. Okay, so the vertex would be, what is our formula? The formula is x equals the opposite of b over double the a. Okay, so what I'm seeing here is, well, it's not an x, it's a p. Price is going to be the opposite of b. So negative 4.19 over double this a. Ooh, boy, what is double that a? So 2 times negative 0.063 is negative 0.126. That makes sense. Double the 6, you get 12. Double the 3, you get 6. And now we divide. Negative 4.19 divided by negative 0.126. That is approximately $33.25. Okay, what price will bring in the most amount of profit? And we just found it. It's our vertex. Okay. Next, what amount of profit will this price bring? Well, that's an M. So we would go M is approximately negative 0.063 times 33.25 squared plus 4.19 times $33.25 plus 24.4. So the millions coming in, let's do that. Negative 0.063 times 33.25 squared plus 4.19 times 33.25 plus 24.4. I just typed that whole darn thing into my calculator, and I ended up with about 94.07 millions of dollars. So that's approximately, right? Just to write this out, $94,070,000 of profit. That's nice. Okay, now before we actually move on to the next example, I want to show you that if I put in here y equals, and I put in our model. Okay, so y is equal to negative 0.063 x squared plus 4.19 x's plus 24.4. Oopsie, I said 2.4. It's really 24.4, isn't it? Yeah. And then I go to graph this. I wanted you to see it's good, not great. I mean, there's our best fitting quadratic, but having this on here lets me know I didn't do a data entry wrong, because I could see how this might not be our vertex, because if it came down, there would be a lot of error over here, right? If it went like this, those would be really far off. And in this way, if it peaks right there, then I noticed that there was this higher profit, but it seems, you know, like, I don't know, it was just a little bit off. Okay, so I do think our model tried to do its very best, and the peak of it happening at 94 million really shaved off a few $1,000,000, but it still modeled some of these other points far better for these expensive ones that were further to the right. Okay, so let's do this again. TV viewers. The average number of viewers watching CNBC's business news is listed in this table according to the year. All right. Average number of viewers per day and the years. So there's a blank here, and we should fill it in because it makes our scatter plots and our models just so much easier. So our counting, let's start at years since 2000. So this would be 0 years since then, 2, 4 years, 6 years, and 7 years since the year 2000. And instead of actually typing these into my list, I'm thinking it would be easier for my calculator and my equations to handle thousands of viewers. And instead I'm going to put in 360, 245, 185, 209, and 273 thousands of viewers per day. Okay, so I am editing my data just to make my equations and computations a little bit friendlier and easier. Make a scatter plot. Okay, so that means right off the bat, we're going to have to clear out this equation. So I'm going to clear that and hit enter. And then I'm going to go second stat plot. And, well, maybe I shouldn't turn this off. And maybe really what I should do is go to statistics, edit. And now notice that in list 3, I have put the years since 2000, and in list 4, I've put the thousands of average number of viewers per day in thousands. Okay, so list 3 is the year, and list 4 is the average number of viewers per day in thousands. And now I'm going to make a scatter plot of this. Before I do that, we need to make a decision. I believe that this is the explanatory variable, so that'll go on the horizontal or the x's, and I believe the average viewer depends on when, so which year. So I believe this is the responding variable, or the y. And I have put this into, so I'm just going to tag it, I put that into list 3 and I put this into list 4, just so that I have my reference. If you put this into list 1 and list 2, fine by me. Make a scatter plot. Okay, so back to second stat plot. We still want it on, but now instead of list 2 and list 3, instead of list 1 and list 2, we want list 3, which is second 3. So second 3, enter, and second 4 for list 4, enter, and now we go zoom statistics for number 9. We get this image. Huh, interesting. So it decreased, decreased, and then it started increasing again. Very interesting. All right. Well, let's write that down. Make a scatter plot for this data. Okay. Explanatory variable. Years since 2000. Okay. Average viewers per day. In thousands. Let's see. So we had this further down and along, and another one here about, and then there-ish. Okay, so here's our scatter plot for the data. And the only thing that I feel like is missing from this scatter plot is what? CNBC. Yeah? Okay. Does this look more like a parabola or more like a line? Well, it's got, oopsie, Y. Ab. So it looks more like a parabola because it goes from decreasing to increasing and it has curvature. It's definitely not straight line. Use your calculator to come up with an equation to model this data. So right off the bat, we are using Quadratic as decided by the curvature. Say what each variable represents. Okay, let's do this again. Stat. Over to calculate. Down to quadratic regression. Hit enter. Not list 2 and list 3. We used list 1, list 2. We used list 3 and list 4. Okay, and now we have an A and a B and a C. And I'm going to round to 2 decimal places. Okay, so rounding to the hundreds place. I'm going to go with, so we have a T here for years since 2000 and the average number of viewers. I'm going to go with V for viewers. Okay, so V is approximately, because remember this is a model based on data. V is approximately 10.01 T squared, so the year squared, minus 84.16 T's plus 364.04, where T equals years since 2000 and V equals av number viewers per day in thousands. I should write in. Got it. Graph your equation on top of your scatter plot. Okay, back to the calculator. Y equals, and I seriously just covered up my, here we go, 10.01 x squared minus 84.16 x's plus 364.04. Graph. Whoa, that's super good. What, I forgot to look at the correlation on this one. But wow, there's very little error here. So it's pretty good at predicting this. Okay, so it says graph the equation on top of your scatter plot. So if I go back up here, it looks something like, okay, and then it actually travels through that one and then hits the tip of this one like that, and then, oh God, rough sketch. Wow. Yowzas, my drawing ability, good, not great. Okay. Rewrite your equation in function notation using V for viewers and T for, oh, well, it's your lucky day. I have already almost used that. V of T. So the only thing I need to change is this, because I like using t's and v's instead of x's and y's. Is approximately 10.0. Oopsie. I forgot the 1 before I was going to write my t squared. 10.01 t squared minus 84.16 t plus 364.04. There it is in function notation. Input a time, and this thing outputs thousands of viewers per day. Ugh, glare. Compute v of 13 and interpret the answer. So here, t equals 13. And then the viewers would be, I'm going to put a 13 into each one of these. 10.01 times 13 squared minus 84.16 by 13 plus 364.04. V is approximately, let me quit that and go 10.01 times 13 squared minus 84.16 times 13 plus 364.04. 961.65 is what I ended up with. Interpret your answer in terms of this situation. Okay, I can do that. T is 13, that's in the year 2013. There were, this is in thousands, remember, so 961,650 viewers per day on average. In that year, there are about 961,000 viewers per day. Nice. Estimate when the least amount of viewers is going to happen using both your equation and your graph. How many viewers would that be? Okay, well, if we use the equation, remember that the vertex formula is x equals the opposite of b over double A. So here, t, the opposite of b would be 84.16, and then double the A, 20.02. 84.16 divided by 20.02, about 4.2. Okay, so the first question is when? Okay, you can't say when. Oh yeah, 4.2 is when. No, this is years since 2000, so in about 2004, right? They would have the least amount of viewers on average. And how many viewers would that be? There was about, okay, and now we have to plug in 4.2 into our model. So 10.01 times 4.2 squared minus 84.16 times 4.2 plus 364.04. About 187,140. Okay. 187,144 viewers per day. Okay, so I went ahead and used the vertex. So this is me using my equation, right? I used the formula to find my t value. That gave me the year. And then I used that t value and plugged it into the model to find how many viewers there were. Now, when we're talking about using the graph, that means we have to go back to this thing and back to the graph, and then we go second calculate. Calculate the minimum. That's the left side of the minimum. And now I'm scrolling over, and that's to the right of the minimum. My guess is somewhere in between. And here's what it says. Minimum happens at 4.2 for the x value, which in our case is the t value or the time. And that happens at about 187.144, and that's in thousands, right? So 187,144. So notice how close we are. We just rounded their answers a little bit. Yeah, they included more decimals, and I just shaved off some of those decimals by rounding. So in order to do this using your graph, you actually have to do the process. Okay, so we went graph, second, trace, which was calc, and then we went down to 3 to find the minimum. And then we had to do left bound, right bound, guess, and then it did the job. But it still ended up with the same answer, so that's important. All right. Use your model's equation to predict when there will be 325,000 viewers. Ooh. Okay, so that means V equals 325. Well, that says we have to put this in where the V is of our model. So I'm going back to our model. V equals this. Okay, so we are saying that 325 is equal to 10.01 t squared minus 84.16 t plus 364.04. Okay, I don't know if you see it, but I see a quadratic equation. So we have to follow our steps in order to solve this quadratic equation. Okay, step 1. Set equal to 0. I have to subtract this 325 from both sides. So we have 10.01 t squareds minus 84.16 t. What is 364.04 take away 325? That is 39.04. Okay, so I subtracted 325 from both sides. Got it. And now step 2, ABC. Okay, so there's my A, my B, my C. Step 3. I'm not writing them down just because I don't have enough space, I don't think. So step 3 is formula. And the formula says, okay, well, instead of x's, I'm using t, is the opposite of b, so 84.16 plus or minus the square root of negative 84.16, that quantity squared, minus 4 times, I'm going to run out of space. That's fine. These numbers have a lot of decimals. 4 times A, which is 10.01, times C, which is 39.04. Okay. All over double this A, which is 20.02. Woo! Okay. So T equals 84.16 plus or minus, and now I'm going to do this entire radical here. So square root of parentheses negative 84.16 squared minus 4 times 10.01 times 39.04. I get about 74.3 or 29, 74.29 about. Okay, and now either or. Okay, so the either or is either we're adding or we're subtracting. So either t equals, okay, 84.16 plus 74.29 is 158.45. So 158.45 divided by 20.02, which is about 7.9. Or t is, okay, we do our subtraction. 84.16 minus 74.29. We get 9.87. These should all be approximations. We've done rounding. Okay. Or t is, divide it. Divide by 20.02 is approximately 0.5. Okay, so what did we just answer? Use your model equation to predict when there will be 325,000 viewers on average. Well, what is this? Years since 2000. So I see 2008 and actually right around 2000. So, or let's say this will happen. This will likely happen just before 2008. Just before, or what likely did happen. 2008 and halfway past the year 2000, or halfway through, or did. I realize that's not grammatically correct, but it's at least more mathematically correct because it's past. This did likely happen just before 2008 and halfway past 2000, or halfway through. Okay, in the next video, we are going to make sure we've been using a model for the consumption of bottled water in the United States, and we're going to make sure that model is actually accurate.